So, just your initial opinion, the spinner has three numbers on it, 1 to 3. Would you expect to get a total of 6 or sum of 6 in 4 spins? So would that be reasonable? Thumbs up if you think yes, thumbs down if you think no. And obviously 6 is a possibility, but we're looking at 3 spins. So most of you are saying no. AJ, why do you think no?
It's the most common one maybe at 3, 1, and 1, 3.
Okay, so AJ is saying no because it's not the most common one. What if you flipped a coin 10 times? Would it be reasonable to get 6 heads? Would it be reasonable to get 6 out of the 10 heads? Okay, probably. So what we need to do is start to develop a little more mathematical, a little more precise definition. What would be reasonable to get? Not saying possible or impossible, because obviously you could get a total of 6. We need to determine where's that cutoff point. What is going to happen most of the time? And that's what our mean and our variance and standard deviation will help us to define. So for one spin, well, we've been doing where we take our frequency times our number and then divide by the total outcomes. You could also take the probability times each number, because that's the same thing as the frequency divided by your total. So we could do, there's a 1/3 chance of getting a 1, a 1/3 chance of getting a 2, a 1/3 chance of getting a 3, or 2. That's the same as if we had added 1 plus 2 plus 3 and then divided by 3. We're just working in our division, the dividing by 3 numbers is part of that probability. Okay, so we could look at it either way. Our variance, our mean is 2. So one of our variances, let's see, 1 minus 2 squared, getting a spin of 1. How likely is getting a spin of 1? 1/3. So we could take it times a third. Okay, there's one way to get that variance deviation plus, and then we could get a 2, so 2 minus 2 squared. There's a 1/3 chance of that happening. Plus, well, there's a 1/3 chance we get a 3. 3 minus 2 squared. 1/3 chance. So then we end up with 1 squared times third, so third plus 0 plus a third. Two-thirds is our variance for one spin. So then our standard deviation is square root our variance, square root of 2/3, and we're not really that interested in what that approximation is, because really we're interested in the 4 spins for this problem. So 4 spins, let's see, well 4 spins is just the sum of one spin 4 times. So we could do, add our means together itself 4 times, and we could do the same thing with the variance, and then use that to get our mean variance for the 4 spins problem. That's what you looked at yesterday. So for 4 spins, what's the mean? What's it going to be? 8, right, 8. Because there's 4 spins, the mean of each individual spin is 2. 4 times 2 is 8. Okay, our variance, well variance, same idea. Yesterday we learned that we could add variances when looking at an experiment where we're adding the results of each individual one. So we get 8/3. So then our standard deviation is the square root of 8/3. From a purely mathematical point of view, we'd simplify this. Now, when you're talking with people and giving stats, do you think people say, well, it's, the standard deviation is 2 times the square root of 3 divided by 3. Do you think they'd say that? Yeah, they're gonna say it's about. Okay, so if you're actually reporting these out, you'd say, well, it's about, in this case, 1.633. Okay, so in terms of talking about it, the approximation is good on these because that's what you would actually probably, let's see, so a total of 6 and 4 spins. So let's see, total of 6 and 4 spins. Well, let's see, we have, our mean is 8. 8 plus minus 1.633. If we did our mean and added and subtracted our standard deviation, most results, not all of them, but many of them, and I think it's around 68% of the results should be within 1 standard deviation of the mean. So here, most results are within 1 standard deviation of the mean. So in this case, let's see, 8 minus 1.6 would be 6.4 to 9.633. So if we did this a bunch of times, most of the time we would get a total between 6.4 and 9.6. Is 6 within that range? No, but 7 is. Most results would fall in range. So 6 is no, 7, yes. Now keep in mind, that doesn't mean the 6 is impossible. It's just not likely. I think we're going to skip over this table because we did that yesterday, basically. I want to look at the question at the bottom. Suppose you flip 100 coins. Would getting 40 heads seem reasonable? Justify your answer. So 40 heads. 40 heads, so let's see, let's figure out 1 toss and then we'll see what else to do. 1 toss. What's the mean for 1 toss for the number of heads? 1/2, right? Because either you get 1 or 0, 1 plus 0 divided by 2. So 1/2. So then our variance. Okay, our variance, well, let's see. There's a 1/2 chance we get a 1, so 1 minus 1/2 squared. And there's a 1/2 chance we don't get ahead, so 0 minus 1/2 squared. So let's see. 1/2 squared is a quarter. Half of a quarter is an eighth, so we get an eighth plus an eighth is 2 eighths. Or 1/4. Okay, so now we could find the standard deviation for 1 toss, but it's not asking about 1 toss, and I could use the variance anyhow when we had it, so I'm not even going to bother with it. So if we did 100 tosses, well then our mean toss is, the mean of the single toss is a half, obviously 50. And then our variance, just adding a quarter to itself 100 times. So 25. And if we know the variance, then we get we know our standard deviation, so our standard deviation is 5.